Hello everyone, welcome to Algebra 1 with Miss Betsy. Today we are going to begin learning how to factor trinomials that have a coefficient other than 1. So this is a little bit more involved than what we've been doing up to this point, but it's still something that once you learn the procedure and once you get some practice under your belt, it's really not all that difficult, and it can be pretty enjoyable as well. Before we get started, got a lame joke for you. And did you hear the one about the restaurant on the moon? Well, you know what? It's got great food, but it just has no atmosphere whatsoever. Now, if you're tracking with me, I am using as my text Algebra 1 for Christian Schools. It's published by Bob Jones University Press. I'm using the second edition. I'm in Chapter 9, Section 9.5. It's called Factoring Trinomials of the form ax squared plus bx plus c. Now, all we're talking about when we use this is just a general representation. A, B, and C are constant numbers, and then we have our variables. So an example of a polynomial that would be of the form x squared plus bx plus c would be 3x squared plus 5x plus 4. Now that one's actually not factorable, but it's still an example. We have three constant terms. Our a in this case is just a 3. This is also an example of a trinomial that takes the form ax squared plus bx plus c, except in this case our a right here, our value for a is just a 1. And we understand that when we have 1x squared, that leading coefficient, we don't actually show. So when they're talking about polynomials that take the form ax squared plus bx plus c, they're specifically eliminating this first one here where you have an understood coefficient of 1. So this is going to be any whole number other than 0 or 1 would be the coefficient for our first term. Now, in order to learn how to factor polynomials that look like this, what we're going to do is go ahead and take two factors together that multiply and see what trinomial we get. We have 3x plus 2 and x minus 5. 3x plus 2 and x minus 5. We know how to multiply two polynomials together by using FOIL. We multiply our first terms together. 3x times x is 3x squared. We multiply our outer terms together. 3x times a negative 5 is a negative 15x. We multiply our inner terms together. 2 times x is a positive 2x. We multiply our last terms together. Finally, 2 times a negative 5 gives us a negative 10x. We have two like terms, negative 15x and 2x. When we combine those, we have not 3x cubed, 3x squared. I'm not quite sure where that 3 came from. 3x squared minus 13x minus 10. So we have this trinomial, which we arrived at by multiplying these two binomials together. Now, let's see what happens if instead of the 3x plus 2, x minus 5, we still use the same terms in here, but we combine them differently. 3x minus 5 times 3x plus 5 times x minus 2. 3x and x 5 and 2, but we had a negative 5, we had a positive 2. We've changed that in our second problem to a positive 5 and a negative 2. Now let's go ahead and FOIL and see what we end up with. First terms multiplied together again is simply 3x squared. Outside 3x times negative 2 is negative 6x. Inside terms multiplied together plus 5x. Last terms multiplied together minus 10. We collect like terms and we have 3x squared minus x minus 10. Same factors, two totally different trinomials. So look at what we did. We factored our negative 10. We have a pair of factors of negative 5 times a positive 2 that we used in our first problem. Down here we have a positive 5 and a negative 2 that we used in the second way that we multiplied these problems together. So while both negative 5 times 2 and positive 5 times a negative 2, while both of those give us a product of this negative 10, you end up with a different center term. And this is what we're going to have to be dealing with when we try to factor trinomials. Whoops, here's a trinomial. When we try to factor the trinomial where the first number, what we call the leading coefficient, where that leading coefficient is greater than 0, I mean greater than 1, where it's 2, 3, 4, or negative 1, negative 2. Misspoke twice. Where this leading coefficient is a whole number that is different from 0, 1. Whether you have a positive 3x squared or a negative 7x squared, we're going to have to be dealing with some possible different combinations of factors, and this is the key that you need. We have what? Remember, we have FOIL. Let's see, yes, you can see me FOIL. We have the first terms. What's the that's the outer term, and this is the inner terms. So we actually, partial products are what we have actually 4 partial products here. Means that when we're multiplying these two binomials together, first we multiply these two, then the outside, then the inside pair of factors, and finally we multiply together the last pair of factors. So we have 4 partial products, and we're going to deal with 2 of those. We're going to take the outer term, or the outer product, if I can spell, plus the inner product, and this has to equal the term bx. Okay? What do I mean there? It sounds weird. Well, look here. We have trinomials that take the form ax squared plus bx plus c. This is the bx that we're talking about. And what this is saying, when you FOIL your 2 binomial factors, you figure out what the outer product is. Here's our outer product. 3x times a negative 5 gives us a negative 15x. We figure out what our inner product is, which is the I in our acronym FOIL. The inner product here, 2 times x, is plus 2x. You combine those 2 inner products together, and that inner product, the sum of the outer and the inner, that sum has to equal the center term, the middle term of our trinomial, which is bx. What's our trinomial here? Negative 13x. When we add the outer and the inner products together, we get a negative 13x. When it's arranged this way. With this second way that we showed of possible combinations of factors that equal a negative 10, when we added our outer product, which was a negative 6, and our x, and our inner product, which is a positive 5x, we ended up with negative x for bx, negative x for our center term, which is not what we need. So this right here, the outer product plus the inner product, has to equal bx. It has to equal the center term of the trinomial that we're trying to factor. So now, let's go ahead and do a couple of problems where we step exactly through what I'm explaining to you. This is something where I can step through it and try and teach it to you and explain how the outer product plus the inner product has to be the center term of your trinomial. But you do still have vocabulary that you've got to understand. You've got to be real comfortable with multiplying algebraic terms together. And this is another one of these. The more practice that you have, the better you will do. So we're going to go ahead and do example number 1 on page 380. And this says factor 3x squared plus 5x plus 2. So what's the very first thing that we want to do with this problem? Always, whenever you're factoring, you're going to look for a common monomial factor first. There are no variables in common. 2, 3, and 5 are prime numbers, so there are no common monomial factors at all. Now the first thing that you're going to do is factor the first term. What do we have when we factor the first term? Well, 3x squared is equal to x times 3x. Could also be negative 3x times a negative x, but we're not going to do that because we don't need any negative factors. All of our signs here are positive. We know that when we factor a binomial, a trinomial, that we are going to have 2 binomial factors. And this first term that we have factored, we're going to take that factored form and put these as the first terms of our binomial factor. Now, we know that our signs are positive. We've learned that before. If you don't remember that, look at some earlier videos. And what's going to be the last term? The last 2 terms, what's going to be the factored form of this third term in our trinomial. And how do you factor 2? Well, they're starting us with a really easy thing. 2 can either be 2 times 1, or it can be negative 2 times a negative 1. We have no negative signs, so we're not going to use negative factors. So the only possible factors that we have of 2 are positive 1, positive 2. But how do you know which one goes where? When we just began factoring things where the leading coefficient was 1, it didn't matter because you're saying 1 times something, 1 times something. Here, am I going to multiply 3 by 2? Or am I going to multiply 3 by 1? And this is where those partial products come in. So we have 2 possible ways that we can combine this. We can either say that we have 3x plus 2, x plus 1. Or we can say 3x plus 1, x plus 2. 3x plus, x plus. We're going to do our partial products. Remember over here I wrote that we find the outer product, we find the inner product, we add them together. What's our outer product? 3x times 1. We have 3x. What's our inner product? 2 times x plus 2x. When we sum these together, what do we arrive at as our solution? Well, that's 5x. What happens now? What's our outer product? 3x times 2 is 6x plus the inner product, 1 times x plus x is equal to 7x. So we have two completely different problems. Two completely different results when you multiply these pairs of factors together because of what you're multiplying by 3. Now you saw, I'm sure, that this is going to be our correct factorization. You saw that first. Why? Because the sum of the outer product of 3x, the inner product of 2x, is 5x, which is that center term in our trinomial that we're looking for. And this is represented by bx in our generic formula. We tried this other pair here. The sum of our outer product and our inner product was 7x, or 5x is not equal to 7x, so this is not the factorization. So this is how we have arranged together these two problems, these two factors. We factored the first term to get x plus 3x. We factored the last term so that we could only use 2 times 1. And then we trial and errored, if you will, create a word there, to see which combination of factors worked. This one didn't. This one did. This is our solution. Okay? Let's go ahead and try another problem. The next example is 2x squared minus 9x plus 4. 2x squared minus 9x plus 4. We have a trinomial. We know that will factor into two binomial factors. What are we going to do for our first terms here? So that we factor our first term in the trinomial. 2x squared can be written as 2x times x. Now what's the first step here that I neglected to articulate to you? We always first check for a common factor in that trinomial. Are there any common factors? No. 2 and 9 and 4, no common factors. So there's no common monomial factor. The first thing that we do is factor the first term and use those factors in our binomials. So we have 2x and we have x. Now, we have a negative sign here, but a positive sign for our third term. So what does that tell us? A negative times a negative is equal to a positive. The only way we can have a negative center term and a positive third term is if we have two negative signs. So our factors of 4 are going to have to be negative. How does 4 factor? Well, 4 can be -1 times -4, or it can be -2 times a -2. There's no other way that you can factor 4. So, let's go ahead and do our trial and error and see what happens. Let's begin with this. So we're going to have 2x, we're going to have a -2, an x, and a -2. What do we want to do now? Let's see what our outer product is. Our outer product is 2x times the -2, -4x. What's our inner product? Our inner product is -2 times x, -2x. The sum of our outer and our inner product is a -6x. Do we have a -6x up here? Well, no. We don't. So this arrangement of factors, while it's true that -2 times -2 gives us a +4, when we plug those factors in to these two binomials, we don't get the right trinomial. Now let me show you another little tip here to look for. Sometimes it happens this way and sometimes it doesn't. What do you notice in this first binomial here? Give you a hint. Has a common factor of 2. If you are always careful to check that you have no common factor in your trinomial, there will not be a common factor within a binomial. So we could have automatically eliminated that one as soon as we saw it gave us a common factor. But I wrote it out on purpose so you'd see, okay, we'll try this one, and the sum of our outer and inner products doesn't work. So now we know that this next one had better work. We have 2x minus 4 times x minus 1. Because we know it has to be those two factors, right? Well, what's our outer product? Our outer product, 2x times a -1. -2x. What's our inner product? -4 times x, -4x. What's our sum? -6x. We needed a -9x. So this doesn't work. But we know it has to be this pair of factors because -2 times -2 doesn't work. So, what's going on here? You got it. We're going to change their order. 2x minus 1 times x minus 4. Now, let's see what our partial products are. Outer, -4 times 2x is -8x. Inner, -1 times x, -x. And there we get our -9x. So this is the factored form of 2x squared minus 9x plus 4. How do you check it? I'll show you exactly what you do to check it, and I'm sure that you're already remembering what you do. I'm going to go ahead and erase all of this junk and say that we said 2x squared minus 9x plus 4 was equal to 2x minus 1 times x minus 4, which is what we showed down here. How do you check it? You simply FOIL. Product of our first two terms, 2x times x, 2x squared. Of our outer terms, 2x times -4 is -8x. Our inner terms is -x. Negative 1 times the negative 4 is a positive 4. We combine our outer and inner terms, the like terms, outer and inner partial products, which are like terms. 2x squared minus 9x plus 4. That is the check to show us that we did, in fact, correctly factor the trinomial 2x squared minus 9x plus 4. Okay? Let me go ahead and do one final example for you. And I'll remind you that if you understand the process that we're following, how we're factoring the first term and the third term and looking for pairs of factors so that the sum of the outer product and the inner product is equal to that center term of the trinomial, then the more that you practice these, the more proficient at them you will become. So let me do this one here. 6x squared minus 14x minus 40. X squared minus 14x minus 40. This is one, I'm not going to do it in exactly the same order that it is in your text, because there are a large number of possible pairings of factors here. And what you will find is the more practice you obtain in factoring trinomials, the more rapidly you're able to come up with the proper factors. You're able to do things in your head. You can eliminate out of hand some of the pairings of factors, so it narrows your answer down more quickly. First off, what do we want to do here? Do we want to go ahead and factor 6x squared? No, we don't. And the reason for that is we see that all of these are even numbers. So we have a greatest common factor, a common monomial factor that we need to remove, which is 2. Now we have 2 times 3x squared minus 7x minus 20. We have no more common factors because we have even and odd numbers in there. There just isn't a common factor. So now we are going to factor this trinomial, 3x squared minus 7x minus 20. We know that factors into a binomial. Do not fail to add this first factor. Don't forget to add your common monomial factor. We're going to have 3x and x. Somewhere, that much we know, because there's only one way that you factor this first term. Now let's look at these signs over here. We have a negative 7x, we have a negative and a negative. What's the only way that you can get a negative product? Well, you're going to have a positive term and a negative term. So it's going to be positive and negative, negative and positive, and there are a bunch of different ways of factoring 20. So we're going to have to play around with this for a while. How can you factor 20? And we know that the terms have to be opposite. The factors have to be opposite signs, negative and positive. Well, 20 could be negative 4 and a positive 5. It can be positive 2 and a negative 10. It can be 5 and a negative 4. All of those products that result when you carry out these multiplications are all 20, like negative 20 like they're supposed to be, because we need negative 20. I'm not going to take the time on this video to go through all 99 bazillion pairings that we have. Let's see, they showed 6 pairs of factors in the book. We're just going to go through these 3. What can we do? Well, we have 3x minus 4 times x plus 5. We could do 3x plus 5 times x minus 4. We could do 3x plus 2 times x minus 10. We could do 3x minus 10 times x plus 2. Let's see what some of our partial products are now. Remember, the partial product that we're looking for, the sum of, is the outer and the inner terms. What do we have for our outer partial product? 6x times 2. 3x times 2 is 6x. That's the outer. Plus negative 10 times x. Negative 10x. So that's a negative 4x. We're looking for negative 14. What do we have here? Our outer product, 3x times the negative 10, negative 30x. This is not looking good, is it? Inner product, 2 times x plus 2x. Their sum is negative 28x. Okay, we're getting worse. First one side of the negative 14. I'm sorry, one side of the negative 7. The other side of the negative 7. Now look carefully what I said. How my tongue slipped. I said the negative 14. This is not what we're factoring. We are factoring this trinomial. So the sum of our partial product for which we're looking is negative 7x. Okay, let's see what happens if we do this one. Our outer partial product, 3x times 5, 15x. The inner product, negative 4x, 11x. Not what we need. This one right here, outer, 3x times negative 4, negative 12x. Inner, 5 times x, plus 5x. Sum is negative 7x, which is the one that we're looking for. This pairing of factors. The more you do them, the more you work through this process, the more it becomes second nature to you, and the more readily you're able to say, okay, it's not this one, not this one, not this one. It's one of these two. Let's see which it is. Oh, this is what my answer is. 3x plus 5x minus 4. Now, you are foolish, in my opinion, to stop at this point in your problem. Why? Because you can go back and check it to make sure that you have solved your problem correctly. So why would you not take the extra time to do it? What are we going to do first? We're going to multiply together our two binomials. 2 times 3x times x, 3x squared. Outer, 3x times negative 4, negative 12x. Plus the inner, which is 5x, plus the outer, which is a negative 20. Now what do? We are going to collect like terms. Now, alternatively, you could have said 2 times 3x plus 5 is equal to 6x plus 10, and then multiply that. And actually, that would be doing your multiplication in order from left to right. We're going to do it this way first. 2 times 3x squared minus 7x minus 20. Now we distribute the 2 times 3x squared, and 6x squared, 2 times negative 7x, negative 14x, 2 times a negative 20 is a negative 14. And you have verified that the product of these three factors is 6x squared minus 14x minus 40. So now, let me take just a second and show you, illustrate for you what would have happened had we actually said, okay, I'm going to do my multiplication in order from left to right. Because what I did was I changed the order in my head. But let's just say 2 times 3x plus 5. 2 times 3x is 6x. 2 times 5 is 10. Now we have two binomials that we're multiplying together. We're going to FOIL our first partial product, 6x times x, 6x squared. The outer, minus 24x. The inner, plus 10x. And the last, minus 40. You collect like terms. 6x squared minus 14x minus 40, which, of course, is the problem that we began with. Spend time on these. The only way to gain proficiency in factoring trinomials is with practice. Enjoy them, and I'll see you next time.